digestive tract when needed. Okay? So, if needed, like in times of an extreme stressor, okay, we have the enteric nervous system. It's a system, doesn't have anything to do with coming from the brainstem or the spinal cord, okay? But it's a system that can innervate smooth muscle of the digestive system and glands. Now, the glands that you would have in the digestive system, these would be mucus, okay? Because you're helping to break down foodstuffs. The neurons are in the walls of the digestive tract. They make their own reflex arc because there's nothing that goes to the central nervous system. This is a completely local system. It kicks in when needed. The job, regulate motility of my esophagus to allow for swallowing. So that if you're trying to eat, but you gag and it makes you not eat, you're not going to get any nutrients to your body, which is something that happens in the sympathetic response. This tries to help so that you will at least eat something minimal. Help with motility of the stomach. Help break down the food stuff you've just eaten. In the intestines, we need to make sure that we get digestive enzymes and that material can move through the intestines to the large intestines and leave the body so that you're not getting waste built up. So, under normal circumstances, our sympathetic, parasympathetic are taking care of things. Note my terminology. In a time of extreme stress, the enteric can take over. So it is a division that we have.
So if a person is sick, would they be in a sympathetic or no?
What do you mean by sick?
Like, well, like she mentioned, well, you guys mentioned something about like the menstrual period stops, like if you're like in the sympathetic for a long time.
Mm-hmm.
So like I was hospitalized for like a year, and during that time, like I didn't menstruate at all, and then it took me like almost 2 years to get back on menstruation.
Now that could have been due to, yes, stressor of being in a hospital for that long, being sick, but it could have also been what was, what put you there. In other words, what was the reason that you were in the hospital for that long? So it would just depend on what the situation was. Yeah.
But if it's just like a normal, like if somebody has a fever, it's not going to be.
No. Shouldn't. It shouldn't. If it is, usually indicative of something else being present. So this enteric nervous system can work when needed. Something else that can happen in times of things going wrong with the enteric nervous system, Hirschsprung disease. Ever heard of that?
No.
Okay. Well, me either. Okay. It's not really something that is fairly common. Okay. Note, hereditary defect, meaning something had to go wrong in the genetic makeup. Okay. This causes an absence of this entire system. This means we don't have any innervation to the colon and rectum. That's not good, okay? Basically, the colon and the rectum are permanently constricted, and there's no passage of feces. So, from whatever point that rectum and colon are constricted, and if you note how that structure works, okay, so whatever point constriction occurs, the entire rest of it gets impacted. Now,
Is that when people start getting fully
it would have been something evident from birth. So it wouldn't just come about at a point later in life. It would have been present from birth, because newborns, if they fail to have a bowel movement, this is one of the things they check for. The impaction, of course, is dangerous in itself, okay? But the other part about that is you're not getting rid of any of those wastes that are in the feces. So these toxins are building up in the body. When we get this massive dilation of the bowel, and yes, the people who have this, doesn't mean they can't live, okay? Life is just difficult for them. And when they get the dilation, they call it megacolon, because it will literally expand hugely in the body. And a lot of times they have to go in, have surgery, get it removed, this sort of thing. The other part, because of that distension that will take place, that's damaging the tissue, and it can create little tears. And if that happens, and if we're having all that waste back up in these areas of the body, gangrene can set in, okay? So at this point in time, I don't know if there's any treatment or cure for this. Last time I checked, it's not, okay? Now, this part that we're getting ready to move into for this system, I want to go back to what I said earlier. The two divisions, parasympathetic, sympathetic. Each one has neurotransmitters. Each one has receptor cells, so they have a target. However, depending upon the system, those neurotransmitters can be excitatory or inhibitory. Okay, this is what we're going back to right now. So, at the point when we started this chapter, the neurotransmitter that you guys were familiar with was the one that you had learned about for skeletal muscle, right? The acetylcholine. Well, as we have seen going through some of this information, we brought up some other neurotransmitters. We brought up epinephrine, norepinephrine, dopamine, okay? We have brought up some because there's I'd be afraid to say, I don't even know if they know how many neurotransmitters we have in our body or how they even work, okay? Because we're learning that every day. So we have more than just these hormones that we're getting exposed to right now. So, cells of the body, do you guys remember in part one and learning about the structure of the cell and that glycocalyx and those carbohydrate chains that came out, they could form a receptor, and some of the proteins that exist in the plasma membrane can act as a receptor. Does everybody remember that? Okay. All cells of the body have receptors. All right? It's just that not all cells of the body accept every chemical. Does that make sense? All right? Every cell of the body has receptors for what they need or what can affect them. So, target cells vary. Okay? The receptors don't always have to be the same on every cell. So, okay?
Is norepinephrine just the opposite of epinephrine? Is it like a canceling, like excitatory versus inhibitory?
Actually, we need norepinephrine to get epinephrine.
Mm-hmm.
So,
but it was a very big difference. Like it was a tiny bit of
Yeah.
a nor.
So when we get into the endocrine system, we're going to actually see how those two work together. But we actually, NOR is the precursor to epi.
Okay.
Okay? So even though there was a small amount, based on the way that the chemicals work, okay? So it will be a precursor to epinephrine. So, if receptors can vary, target cells, all right? Now remember, if I'm thinking about my two divisions, my sympathetic and my parasympathetic, hopefully in part 1, you learned that each organ, okay, do you remember the levels of organization that exist? Molecules make up the organelles, organelles make up the cells, cells make up tissue, tissue makes up an organ, okay? So that means the cells of these tissues, okay, vary as well as their receptors, okay? So, every single one of these viscera are target cells, okay? They can respond to the same neurotransmitter. For example, acetylcholine. But it doesn't have to act the same, okay? Epinephrine, dopamine, serotonin, whatever the case might be, that it can be the same neurotransmitter, but due to what the receptor is on the target cell, the response can be different. So, for example, once again, I'm mentioning acetylcholine because you were introduced to that in part 1. In part 1, you should have learned that that was the neurotransmitter between the nerve cell and the skeletal muscle cell. And it was excitatory. That's all you learned. Correct? Okay? Now, we're seeing that we have acetylcholine, a neurotransmitter. We're looking at totally different tissue types meaning totally different cells, okay?